Okay, all of this, just like any other thing in math, when we're teaching something in our content area, you can't just teach one standard without addressing a lot of others. So all these other standards are brought up a little bit. They're not really part of the lesson as far as instruction, but we touch on all of these in order to cover the standard that we're addressing. Okay, so just like with a typical lesson, most of us use some kind of warm-up or bell work to activate their prior knowledge. Because these are things that we would want them to already know before we do our lesson, but it's a chance to go back and review. Probably convex and concave, because we're going to be talking about interior and exterior angles of polygons. So we would want to talk about the differences between convex and concave. And just, with your kids, if you can get them off a little, it helps. Okay, and here's some other hooks you could use to show them where polygons are in real life. And we thought that Mario was kind of cool, that you could see all the different polygons in Mario. Used to be able to walk up the sides and not the middle. Shadows. But just some real world application. And another, if you'd like to use a hook, like a warm-up problem type of thing, this one is based off the item specs, which we'll come back to. But this very similar to what they have on the DOE website. That's why I picked this problem. Okay, so we will come back to this later after we do our lesson and everyone knows how to find the interior and exterior of a polygon. Okay, so here's our objective. Students will determine the measures of the interior and exterior angles of a polygon and justify the method used. And we know that that's what we're trying to get at, is them being able to justify and not just see a formula and plug the numbers into the formula and they really don't know what they're doing. So just like we've really been pushing in the last several years to get more to the conceptual understanding instead of just the procedural understanding in math. So here's an activity sheet that's in your folder, activity sheet 1. If they were struggling with the triangles, I would probably, with kids, have to do a couple with them to get them started on this by showing them, this bracelet's banging, showing them how we could divide it into triangles. So you might want to do one with them to show them how we divided it, and then with the pentagon, 2, 3, 4, show them how we could divide it into triangles. So they get the idea. So they're not making like a vertex in the middle of the shape, even though their directions are there, but kids. So I would probably do a couple to get them started. I like this one with the triangles, but. So here's the completed worksheet. But then, and it seemed like everybody was in agreement. We know they give them the formula on the formula sheet, but in real life, you're not carrying around a formula sheet, and if they forget, they can always draw the triangles. Once they do it once, I think they're more likely to remember. This is also great for demonstrating, and again, you can have the kids come up and do it. This is showing over in the table the sum of the angles. And you can drag this so it's not regular. So it's another thing you could do in addition or instead of having them tear. And to show the triangle, you can drag these around with the triangle, and then we can do a quadrilateral and the same thing to show them. Oh, I could hear. Yeah, this one's from Illuminations, from NCTM. But I like this, how they can see. They can see it. Yeah, these are all free. They're all free. But it's nice to let them. And another, if you have a computer lab, everybody has different access to different things, I realize. Okay, and then obviously whatever method you used, and then to go back and talk about the formula, because they basically derive to the formula with any of those methods. I keep standing in front of him. And that, oops. then to ask, can you derive a formula for determining one angle of a regular convex polygon? So we would just divide by n. This one I really like, and it's similar. Was it Scott that said you did? Yes. He did something similar to this. He says he has an applet that's similar to this. I like this one a lot. Keep increasing the number of sides. Well, this is a little bit different, but you. I think it's like 15 sides. It's almost And all the links will be in there, and I have a ton more at the end of the slideshow if people are interested. But okay, so it's talking about the sum of the exterior angles, and it says click on some points to make a polygon. So I can do any polygon that I want, and then when I get to where I want to close it, you just hit OK. So it gives us exterior angles. And then when you, this is the cool part, I think, but I'm a geek, so scale down. Somebody uses this one?
Oh, I've never seen that one before. I like that.
Isn't that cool?
Yeah, that's nice.
Yeah, scale up. Yeah, to show, and then so you could do.
I have not seen that.
Yeah, that would be a quick connect.
Yeah, really quick without spending the time with the cutting and stuff. I know, and then just scale down, and then you just scale any one. I think I did the same thing. Did I do a pentagon before? But you get the.
For about 4 weeks.
Yeah, and then they'll get it. But that one is cool.
They'll be looking for the button on the devil.
Yeah. Okay, so that was another one. Another option, and this may be, those of us that took geometry way back. We did proofs in geometry. I don't think there's a lot anymore, but it may be if you have an honors class. This is proving with a regular polygon, so we put the proof in here. We're not going to talk all the way through it, but we wanted you to have one if you wanted to do it.
Awesome.
Going through the measure of each interior angle, then the measure of each exterior angle, and then the sum. And simplify. Oh, you can't see it that good, and then there's our conclusion. Now that's just for a regular polygon, but then Leslie did the proof for any polygon, and did the sum of the interior angles, we already know, and minus 2 times 180, and then the exterior. So then the sum of n exterior. And you might want to look at it closer later, and that equals 360. So that proves it in general. So this again, maybe the honors class, maybe differentiating instruction, maybe an extension for your kids that they don't want to, maybe the kids that finish early. Okay, why don't you prove this? This is the one somebody said they walked. You could. I saw a teacher draw a polygon on the board and took like a Matchbox car to show going all the way around the outside. Gets to 360. You could tape it out on the floor and have them walk. Then it gets them out of their seats too, to see that when they walk all the way around, they're facing the same direction as they started. I saw this one online, with pencils, but there's a lot of ways to show it. I like the car. They seem to remember that too. And I heard you saying you have them. Did you say you had them walk?
Yeah, you just walk.
Yep. Yeah, around the building. Here was another one. This one addressed to people who were saying the concave too. In the applet, but we weren't probably going to go there with the students, but I wanted to do a screen capture so you guys could see that it does work. But it's just another applet that we can do and showing for the exterior angles. And when you move this, they can see what's happening with the sum up here. But I like that this also shows the angles, because like you were saying, I heard this group talking too about when they draw the exterior angles, it's showing up clockwise and counterclockwise and both. So that was interesting. Just another applet. Okay, now we're going to go back to our original problem.
Scott, I think you're being mean.
I know he's being
It's actually good.
He was very complimentary.
okay.
He said he'd rather
Well, except for Toby.
Okay. So first thing, I found out the angle here for the exterior hexagon. Okay, and so I did n minus 2.
I said exterior. Okay. Yeah.
Which equals 120 degrees. So if these angles are 120, it's bisected here, so it's got to be 60 and 60.
Yeah.
Excuse my lousy.
Yeah, we worked it the other way. You're
Because I
right.
can't see the lines up there.
Okay. So 60 and 60, and anytime you have parallel lines,
Oh, so the wood grain
60
detracted
angles
from the
have to be
lines.
At the 180, so
Is that how you were going to explain it? I've done something.
120.
Try to wrap it up here to give you guys some time to work on some of the other standards. So just, emphasizing the types of polygons, the convex, just like we did when we did the warm-up, and somebody pointed out that I forgot to write convex on the worksheet, so I need to fix that. Multiple representations, which we know that is important with the students, whether you're using online applets, map, cutting things out, measuring. We know it's important for students. It's all best practices that we've all known. They just change the names every few years, but it's all best practices, right? Emphasizing the students making and testing conjectures, probably even more important. We do it more in geometry than the other courses. And then getting the formulas after the activities. I observe a lot of new teachers, and they always give, not always, often give the formula and just have the kids substitute the numbers in. And yeah, they can use the formula, but they don't really know what they're doing. So it's really better for them to come up with the formula, especially one like this that's really not that difficult for them to derive. And then, like we've been saying for years, aiming for conceptual understanding than just doing that, giving them a formula and they work through procedure. And then this is the specs right from the DOE website. That's why I picked the problem, because they had a problem very similar. That was their sample problem. And more of the item specs. And then we would do an assessment, which we're probably not going to do, but I wanted to quickly talk about, do we have time? There's a handout. Most of us probably went to school. We did. I was always familiar with Bloom's taxonomy. Is that what most of you? And now I hear more talk about Costa. Have you heard? But I actually like Costa's better. There should be a handout in there. It's the same idea, but it's a little simpler because sometimes with Bloom they kind of overlap, like application and analysis. I mean, honestly, off the top of my head, remembering the difference between application, I kind of like Costa's better. It's a little more simplified version of Bloom's, but still has the same general ideas. So if you hear people talk about it, I wanted to give that to you. And then when you're doing assessments with your students, we know, the basic, find the sum of the interior angles of a convex hexagon. There's not a lot of thought involved. That's a lower level question. Finding the missing angle, pretty lower level question. Then giving the sum of the measures of the interior angles of a convex polygon is of the interior angles is 1,260 degrees. How many sides does the polygon have? That's a little higher order, I would say. And then just talking about different levels of questionings that we want to make sure I know we want to definitely get to the higher level questions and the deeper understanding, but we still want to we would still need the basic questions too. We need to know also with some of our students where we're losing them. We need to know, can they do the basics? Can they substitute the numbers into the formula and find the answer? And then trying to do the higher order questions. I think I didn't have more. But I wanted to give you this in case you hear people talking about Costa, because most of us are probably familiar with Bloom's, but I really do like how it lines up with Costa. I think